Scattered around in the sand are thousands of chunks of strange yellow-green glass.
It is really, really a mysterious glass, and we scientists are still kind of puzzled how these things formed.
In the heart of the Libyan Desert, geologist Patrick Clayton discovered a substance that shouldn't exist. It gleams like glass, purer than crystal, over 98% silica, and formed at temperatures exceeding 2,000 degree Celsius, hot enough to liquefy granite itself. This is Libyan Desert Glass, even today. After nearly a century of study, scientists still cannot replicate it in the lab without resorting to laser technology. Why does this ancient desert hold a material of near absolute purity? How could nature produce something that only emerges at temperatures rivaling the surface of a star? When Patrick Clayton sent the first samples to Cairo, and then to the Natural History Museum in London, geologists were baffled. Some claimed it was the product of lightning, but there were no traces of widespread scorching or fused rock layers. Others suggested it was the aftermath of an ancient meteor explosion, yet the entire Great Sand Sea shows no crater at all. If there's no impact crater, then what force melted millions of tons of sand in an instant? Those glass samples were later taken to NASA's Ames Research Center and Curtin University in Australia. Under electron microscopes, they revealed bizarre minerals, among them rhyodite, a variant of zircon that only forms under extreme pressure and heat, akin to celestial impacts. But the strangest part, the compression patterns in these crystals don't radiate downward from above, like a falling meteor, but upward from deep within the Earth. If not an impact, if not lightning or volcanoes, then what unleashed energy vast enough to scorch the Earth from below? Many materials physicists call this phenomenon an energy convergence anomaly. Modern simulations show that to form this glass, an intensely high heat source must be focused precisely on a single point, much like the mechanism of a laser beam or a directed energy weapon. These findings evoke a terrifying possibility. The Libyan Desert once endured a massive focused energy blast, powerful enough to melt the entire sand surface in a flash. That event could stem from an ultra-rare cosmic phenomenon, or from an artificial energy source lost to time. For nearly a century, in the quest to unravel this mystery, scientists have built a series of hypotheses from meteor impacts, atmospheric explosions, to natural lightning. But the deeper they dig, the more they realize no hypothesis holds up against the raw data. The first and most popular hypothesis posits that this is the product of an ancient meteor impact. In the traditional model, when a massive meteor slams into Earth, the energy released in that moment can melt desert sand, creating natural glass. This mechanism has successfully explained similar phenomena: moldavite in Central Europe, australite in Australia, or tektite in Southeast Asia. And for years, people believed LDG was just another variant of African tektite. But the problem is there's no crater, not in the Great Sand Sea, not within hundreds of kilometers, no sedimentary structures, no fractured bedrock, no radiating shock metamorphism, the geological signatures that mark every known impact. If a meteor had struck, its crater would be at least 20-25 kilometers across, impossible to vanish completely in just a few million years. When no crater was found, another hypothesis emerged: airburst and atmospheric explosion. In this model, the meteor detonates kilometers above ground, generating shock waves and extreme heat, enough to fuse sand below without leaving a crater. This scenario was invoked for the 1908 Tunguska disaster, where thousands of Siberian trees were flattened with no crater in sight. Airburst seemed plausible until geologists measured LDG's formation temperature over 2,000 degrees C. That's many times hotter than what an airburst could achieve. Moreover, the glass contains rhyodite, a mineral that only forms under crushing pressures of tens of gigapascals, far beyond what airborne shock waves can deliver. So what about lightning? Plenty of hypotheses suggested LDG could form from massive lightning strikes, similar to fulgurite's natural glass tubes created when bolts hit sand. But fulgurites are only a few meters long, narrow in diameter, hollow and porous, while LDG is solid, spread across thousands of square kilometers, and uniformly fused throughout. No single bolt could do that. Some scientists turn to ancient geothermal models, suggesting shallow magma veins beneath the sand might have erupted suddenly. But ground-penetrating radar shows the Great Sand Sea has no such tectonic traces. This is the most stable desert foundation in North Africa: no volcanoes, no stratigraphic faults, no evidence of magma flows in the last 30 million years. And so, every hypothesis hits a dead end. No natural mechanism explains the heat, the pressure, and the scale of the event. In the end, researchers are forced to admit, Libyan Desert Glass is an outlier in Earth's history, a material without a clear homeland. One geologist from the Curtin University team once wrote, "LDG is evidence that Earth has experienced something we don't yet have a name for. Those words send chills down many spines. If all natural mechanisms fail, then what's left? A cosmic event not fully understood? Or a deliberate energy form, wielded in an era when humanity believes no technology existed? But the turning point came in the 21st century. This era's technology began illuminating it with tools that Patrick Clayton or earlier geologists could never have imagined. When transmission electron microscopy (TEM) and AI simulation models were applied to ancient materials research, the results stunned the scientific world. Inside those pale yellow glass fragments, scientists found an atomic-level energy map, structures impossible to create through random natural processes. At millions of times magnification, LDG striations aren't chaotic. They spiral in precise geometric patterns, as if energy was guided by an ordered force field. A physicist at Curtin University called it frozen energy imagery, where shock waves, heat, and plasma once merged into unity, then flash frozen in an instant. Quantum simulations show that to replicate this structure, a focused energy source exceeding 2,200 ELARs and surpassing 30 gigapascals is needed, achievable only by large celestial impacts or directed energy devices. But the damage morphology in LDG's crystal lattice doesn't match an external strike. It bursts from within the material, radiating outward as if an internal energy emitter was right in the heart of the sand. When this data was fed into AI geothermospectral models at MIT's Materials Systems Lab, the algorithm uncovered another oddity. The glass fragments aren't scattered randomly. They form a massive ellipse, nearly 30 kilometers across, with an energy focal point precise to the meter. And right at that spot, ground-penetrating radar detects a subsurface melt zone, hundreds of meters deep, with faint magnetic traces like remnants of an immense electromagnetic pulse. NASA later confirmed this distribution doesn't fit a standard meteor blast. No extraterrestrial material, no nickel or iridium traces the hallmark elements of impacts. Instead, all signs point to a pure earthbound energy release, occurring in an ultra-short time frame, perhaps mere milliseconds. The American Mineralogist Journal 2023 published the final discovery that upended everything. In some LDG samples, researchers found zircon phased into rhyodite, a mineral that exists only momentarily under massive pressures, equivalent to celestial collisions or nuclear tests. Yet there's no evidence of a meteor fall. And of course, no nuclear tests ever occurred here. Experts are forced to acknowledge what's buried under the sand isn't just geological residue, but testimony to extreme energy, a crystal burn scar on Earth, created by a mechanism humanity still can't fully simulate. AI models the thermal zone as a colossal plasma vortex, energy compressed and unleashed in a split second, creating the first recorded non-contact melt in nature. Physicists call it a radiant burst of focused radiation flare, akin to a laser energy beam. But what baffles them is no natural tool on Earth could generate this kind of radiant burst. What they're seeing could be traces of a lost ancient technology, or echoes of a cosmic event humanity has never documented. A NASA researcher said in a 2024 interview, "Libyan Desert Glass may be the result of an energy mechanism that once existed, but can't be replicated with modern physics." And so, with each new layer of data, the mystery deepens. The more we understand Libyan Desert Glass's structure, the more science must confront an uncomfortable question. If this is natural, what exactly is nature? The new findings from AI, TEM, and quantum simulations don't just raise questions about the material, but about the energy source that once existed here. If not a meteor, not lightning, not volcanoes, then what melted an entire desert region with the heat of a star? In fringe research circles, one hypothesis is rising: the ancient technology theory. It suggests Libyan Desert Glass isn't nature's random product, but the surviving trace of an artificial event from an era we still call prehistory. A semi-independent research team from Austria and Egypt compared LDG's molecular structure to trinitite, the glass formed after the first atomic bomb test at Alamogordo in 1945. The results astonished them. Both show directed flow patterns, vaporized silica microspheres, and crystallization interrupted by ultra-short heat pulses. The only difference: LDG is purer and contains no radioactive traces. That means it was created by energy of nuclear intensity, but not based on nuclear fission. Some scientists speculate about focused plasma, a blast from compressed and dispersed plasma energy, similar to high-power lasers or fusion reactors. When MIT's AI model was applied, the algorithm confirmed LDG's energy twist structures match 94% with samples from femtosecond lasers beams that can cut steel without spreading burns. If true, it means the Great Sand Sea once withstood a highly precise focused energy beam, emitted from a source yet unidentified. One big question arises immediately: where did that source come from? Part of the scientific community leans toward a cosmic scenario, suggesting LDG could result from a comet plasma strike, where ionized energy particles bombard Earth like natural lasers. But another part looks to ancient humans, especially the Egyptians. In King Tutankhamun's tomb, among thousands of treasures, there's a pectoral, a protective amulet featuring a scarab carved from Libyan desert glass itself. To the Egyptians, the scarab symbolized the reborn sun, the eternal cycle of light and fire. Strangely, they didn't just pick this material as gemstone. Ancient inscriptions describe fire from the western desert, light falling down, and sand turning to glass. Could the Egyptians have witnessed that very moment an energy blast they called the Flame of Ra? This hypothesis, though controversial, aligns data in a chilling way. LDG is distributed near Egypt's western border, along ancient migration routes to the Nile Valley. Egyptian artifact glass matches LDG's spectrum exactly, with no variance in trace elements. And even stranger, star maps etched on some ancient amulets align with the Great Sand Sea's position, as if they saw it as the touch point between heaven and earth. Many conservative archaeologists dismiss this as coincidence, but in recent scientific conferences, the phrase energy-directed event, a deliberate energy occurrence, is starting to appear. No longer conspiracy, but official terminology for phenomena beyond current physics. Libyan Desert Glass, therefore, is no longer just how did it form, but who or what created it, and why? After more than 28 million years, do those glass fragments remain intact down to 1,000th of a millimeter in molecular deviation? While labs continue to debate, the desert remains silent. But every ray of sun on that golden sand reflecting through those clear shards seems to remind us that what we call myth might just be memories of a technology buried long ago. As new data emerges, the scientific community splits in two. One side believes Libyan Desert Glass is evidence of an ancient celestial impact, a crater erased by time. The other sees the entire impact hypothesis as a desperate bid to preserve old scientific order. These debates don't stay on paper. In geology and planetary science conferences, LDG becomes a flashpoint. Each time one group publishes new results, another counters with conflicting data, and the arguments spiral deeper, like the structures inside the glass itself. The classical school argues that rhyodite, the mineral formed only under extreme pressure, is the clearest proof of a meteor impact. But LDG's crystal lattice morphology doesn't match outward to inward shock models. It radiates from inside out, as if energy erupted from the Earth itself. New TEM electron microscopy analyses muddle the picture further. Formation temperatures exceed any known atmospheric blast. No extraterrestrial matter, no deep fractures, no sedimentary structures. All of it points to an event outside any physical framework. The deeper they probe, the more results challenge scientific faith. MIT's AI simulates spectral data, confirming energy converged in the Great Sand Sea as a plasma vortex, focused precisely like a giant laser beam. But that implies a guiding mechanism existed where none should. Some scientists advocate a more cautious approach if unexplained. Stay silent for now. But silence doesn't erase evidence. For layer by layer of sand, shard by shard of glass, tells the same story of an energy source modern science has only begun to touch. And that's when boundaries blur, when results are too perfect for chance, too sophisticated for nature. Researchers face the hardest choice. Either expand the definition of natural, or admit that, on this planet, a level of technology once existed that we no longer comprehend. Today, no one dares claim certainty. Libyan Desert Glass is still studied, analyzed, simulated. But the more we understand, the more we realize the mystery may not lie in the rock, but in how humanity defines knowledge. Science isn't wrong. It's just not ready to face the possibility that something beyond its scope once happened. In the Libyan desert, where sand still rolls like waves, those pale yellow glass fragments lie silent under the sun. They've been there for over 28 million years, witnessing every change, every civilization rise and fall. But they themselves pure, transparent, unfading, seem to hold a memory humanity isn't yet humble enough to hear. Libyan Desert Glass is more than a geological phenomenon. It's a trace of energy beyond human understanding, a scar etched on Earth to remind us of powers we've never truly controlled. Modern models recreate that blast in the moment of formation. Temperatures may have surpassed 2,000 degrees AC. Pressures warping sand's atomic structure. Some of that energy remains trapped in the crystal lattices, a material memory, as if the desert could remember, recording the explosion in every silica grain. And perhaps, this is the most terrifying part. Libyan Desert Glass doesn't come from a distant past, but a mirror of the future. Today, humanity is learning to harness focused energy. We build fusion reactors, test laser weapons, compress plasma, simulate particle collisions. Each advance edges closer to the kind of power that could melt the ground, just like what happened in the Great Sand Sea millions of years ago. And we believe we can control it. But what if Earth once saw another civilization believe the same? If they, or some event beyond them, unleashed energy that still hasn't faded, beneath those sand layers, altered rock zones may still linger deep underground, with faint magnetic deviations, burn scars detectable by modern instruments. No one knows where that energy truly came from, but clearly, it touched nature's limits, leaving proof in the desert where nothing survives, except memory. When scientists place LDG under laser microscopes, what they see isn't just matter. It's an energy message, a warning inscribed not in words, but in heat. A reminder that extreme energy, if misunderstood, can devour the world in an instant. Today, those glass blocks still lie there, reflecting sunlight like thousands of eyes gazing at past and future simultaneously. They say nothing, but their silence weighs heavier than any explanation. For perhaps, Libyan Desert Glass isn't a mystery to solve, but a warning to heed against repetition, a legacy of fire sent back to a cold world. And as night falls over the Great Sand Sea, amid dunes glittering in moonlight, one can still see them glow like tiny stars, reminding us that, sometimes, the greatest thing a civilization can leave behind isn't a monument, but the scar of the destruction it once wrought.